All right, so we're carrying on with the next section, which is integers or ints. So in Python, an integer is referred to as an int. In the world of mathematics, we are familiar with the symbols plus, minus, star for multiplication, slash for division, and percent for modulus operators. Last operator or modulo percent or modulo operator may not be familiar with you. You don't have to use a text editor you don't have to use a text editor window to run Python code. Down in your terminal, you can run Python alone. You will be represented with the three arrows in the terminal window. You can run them live into active code. You can then run live into active code. You can then run live into active code. You could type 1 + 1 and it'll run the calculation. This mode will not commonly be used during this course. So this is some using Python interactive terminal. So if you're using VS Code, you would have a terminal, or I can do this in Jupyter Lab quite easily as well, but just saying 1 + 1, shift enter, and you get the result. So opening VS Code, we can also write this to run the file in terminal. This will create a new file in which we'll create our own calculator. So first we can declare a few variables. So let's do this. Let's do this over here. So I'm going to say x is equal to 1, y equals 2, z equals x plus y. I'm going to say print z. Shift enter, and I get the answer of 3. So, we created a few variables, and naturally, when you run Python calculator or run this in the terminal, we get the result in the terminal window of 3. We can make this more interactive using the input function. And also say x equals input. What is x? First do the rest, which is y equals input. What is y? And then z equals x plus y. Then print z. Let's run this. Let's just redo this again. Delete the cell. Okay, let me just rerun everything. Kernel, restart kernel. Again. Okay, what is x? So we can say 1, enter. What is y? 2, enter, and I get the answer of 12. Running the program, which is obviously not correct. 1 + 2 is not 12. Running this program, we discover that the output is incorrect. It is 12. Why might this be? Prior, we have seen that the plus symbol sign is used to concatenate two strings, because your input from your keyboard on the computer comes into the interpreter as text. It is created as a string, as text. We therefore need to convert this input from a string to an integer, and we can do this as follows. We can update our code over here. We can say int x and int y. Convert the text into integers. Once again, so 1, enter, 2, enter, and we get 3. So now the result is correct. The use of int x is called casting, where a value is temporarily changed from one type of variable, in the case of a string, to another, here as an integer. We can further improve our program as follows. We can put this all into one line of code. So I can just copy and paste it, at the space. So we can incorporate the casting into our input function. Run it. 1, 2, 3. So this is just making the code a bit neater, adding more functionality to it. So this illustrates that you can run functions on functions. We have input here and an int as well, using the brackets. The inner function is run first, so this is run first over here. And then the outer one is run. Then this one And the brackets is also run. Upper brackets. First the input function is run, then the int function. You can learn more about Python's documentation of int if you go to the page, the built-in functions page about ints. This is the official Python documentation for ints and for the rest of the data types. Readability wins when deciding on your approach to do a coding task. Remember that one could make a reasonable argument for many approaches to the same problem. Regardless of what approach you take to a programming task, remember that your code must be readable. You should use comments to give yourself and others clues about what your code is doing. Further, you should create code in a way that is readable. Float basics. A floating point value is a real number that has a decimal point in it, such as 0.52. You can change your code to support floats as follows. Let's copy and paste this one. And let's see what's happening. So the code is very similar. The only thing that is changing is we are converting it to a float. We're casting it as a float. So to practice this exercise, let's remove it. So I can see practically how this works. Let's run it, and its example is change your user to enter 1.2 and 3.4 to represent a total 4.6, hopefully. So let's say 1.2, enter, and 3.4, enter, and we get 1.23.4, which is obviously incorrect because the input is string. We need to cast it, we need to convert it to a float, and do that by just adding float in the beginning. Use the outer function, float here. Again, 1.2 and 3.4, and boom, we get 4.6. Let's imagine, however, you want to round the total to the nearest integer. Looking at Python documentation for round, you'll see that the available argument is a round number and the number of digits. Those square brackets indicate that something optional can be specified for the programmer. Therefore, you could do a round n to round a digit to the nearest integer. Alternatively, you could do the code as follows. Let's modify the code. Z equals, well, let's make a comment here. Create a rounded result. Remember, with pseudocode with comments. And this is get the user's input. This would be print the result. Z equals round x plus y. So let's run this. And we say 1.2 and 3.4, and we get 5. It is rounded now to 5. Because the value was 4.6, we rounded it to the nearest integer, which is 5. What if we wanted to format the output for long numbers? For example, rather than seeing 1000, you may wish to see 1, 1,00. Could modify the code as follows. So everything stays the same. We just use f string, add f in the beginning, and our quotes, and then put this in brackets, curly brackets, and say colon, comma. Colon, comma. See what result we get, 1.2 and 3.4. We still get that. So although quite cryptic, that print function creates a scenario where the outputted Z will include commas where the result could look like 1,000, 2,500. So in this case, this didn't change. So I just want to know what is the difference that they've done here and why can I see it as well. All right, so just to clarify, this is actually, well, Z will include commas where the result could look like when the values are actually in the thousands. That's what that should means. So it it's not too clear here. So if I have 1,000, 1,000.5 and 2,000, big number like that, it will add commas to the thousands. That's what it actually means. And I did make a quick change, and let me put it back here on the code again. So 1,000 here, 1,000, 10,003, and 2,000. You get the commas. That's what the feature does. But more on floats. How can you round floating point values? Firstly, modify your code as follows. Let's get this code and see what we get here. I'll leave this here if you want to still work through it. When inputting 2 for x and 3 as y, the result is 0.6666. It's recurring, seemingly going to infinity as we might expect. Let's imagine that we want to round this down. We could do this by modifying the code. We can add the round function, round, comma 2 to 2 decimal places. Let's do it again, 2 and 3, and we get 0.67. As you might expect, this will round the result to the nearest 2 decimal points. We could use f string to format the output as well in the same way. So let's just copy and paste it here if you are still following on and trying to code along with me. Let's do 2 and 3, and we get the same result, 0.67. So there are 2 ways to do it. This will force the result to have only 2 decimal places. This just formats it. This just visibly shows it as 2 decimal places. So again, you can learn more about Python's documentation of floats from the official Python file website. So diffs, wouldn't it be nice to create our own functions? Yes, it would. Let's bring back a final code of hello.py by typing code hello.py. Let's have a look at our code. Your starting code will look like this. Maybe it's modified. We can copy and paste this as is. All right, so let's just work on reading it. So starting code should look like this. We can better our code to create our own special function that's a hello for us. All right, so erasing all the code in the text editor, let's start from scratch. Copy and paste this over here. Attempting to run this code, your Jupyter will throw an error. Let's try run it. Let's try and run this code. To click on run and hello.py. Ask for that. What's your name, David? Enter. It says, oh, hello is not defined. Hello is not defined. Attempting to run gives an error. After all, there's no defined function for hello. It doesn't know what hello is. It does not know what hello is. So we can create our own function called hello as follows. So we can put this above our code over here on top. A few spaces. Add it there, def hello, print hello. Save it. And then run this code again, shift enter, and say David again. There we go. David is print out correctly. So notice that everything under def hello is indented. Let's have a look. The indented means there are 4 spaces after this. This is called a code block. So Python is an indented language. It uses indentation to understand what is part of the function. Therefore, everything in the hello function must be indented. Indented just means it has 4 spaces in the front. When something is not indented, it treats it as if it is not inside the hello function. Running Python hello, in the terminal window, you see that your output is not exactly as you might want. You can further improve the code as follows. We can add a variable 2, and then we say print hello, comma, then 2. So who are we saying hello to? And then we input hello, put the name of the person into our function. So we made our function a bit more useful, giving it a value to use. So let's now save and run this. Again, what is the name, David? And enter. What's your name, David? Hello, David. So here in the first lines, you are creating a hello function. This time, however, you're telling the interpreter that this function takes a single parameter, a variable called 2. Therefore, you can call hello name with the input name. The computer passes name into the hello function as 2. This is how it passes values into functions. Very useful indeed. Running Python hello in the terminal window, you'll see the output is much closer to your ideal presented earlier in this lecture. You can change it further on our code to add a default value to hello. So we can also say changes and make it. So make it default. If we don't have input, we can say 2 is equal to world. So we don't have an input. Just do it as well. Test out the code itself. So if we run this again, just says what's the name. And well, in this case, it actually probably took the empty space. In your code, it will probably be hello world. So run it again. Let's say world. So hello world. This terminal on Jupyter Lab works a bit differently. In yours, it should get the correct output. So output will be hello world. Okay, so we don't have to have our function start for a program, for example. We can move it down, but we need to tell the interpreter that we have a main function and a separate hello function. Right? So let's do that. Go to hello function and define that. We can say def main. This would be comment pseudocode what's happening, output using our own function, name equals input. What is your name? And then hello name. And then can do output without passing the expected arguments. Just hello on its own, and then this stays the same, this stays the same, this stays the same. So if we run this now, let's see what happens. It might work but differently in Jupyter Lab. Let's see. So let's see what happens. Nothing happens. This alone, however, will create an error of sorts. If we run Python alone, nothing happens. The reason for this is that nothing in this code is actually calling the main function and bringing our program to life. The following very small modification will call the main function and restore our program to working order. Let's do that then. Let's say main. Run it again. Hello. What's your name, David? There we go. Oh, not that. I should put this work correctly. So returning values. Now that actually hello world does work because it's in this modular file. Returning values. So you can imagine many scenarios where you don't just want a function to perform an action, but also to return a value back to the main function. For example, rather than simply printing the calculation of x plus y, you may want a function to return a value of this calculation back to another part of your program. This passing back of value we call a return value. So return to a calculator.py file. Where's our calculator.py? Okay, let's create one then. Create a new file, Python file called calculator.py. And let's paste this code. So we erase all the code and rework the following. So we have a main function. gets a value for x and finds the square. And the square is represented by just multiplying the value by itself and pulling the function there to bring it to life. Effectively, x is passed to square, then the calculation of x times x is returned back to the main function. So let's see what happens if we run that code. So run run calculator. Let's run it. So look at 3, and I get x is 9, so it's a squared value, which is correct. So through the work of a single lecture, you have learned abilities that you will use countless times in your own programs. You've learned about program, functions, bugs, variables, comments, pseudocode, strings, parameters, formatted strings, integers, principles of readability, floats, creating on functions, and return values. Great. That's it for this lesson. Stay tuned for more. Thank you very much.